Welcome back, folks. Continuing on with using mesh currents so that we can build up to mesh analysis. Once we have these mesh currents figured out, how do we use them to find voltages in the circuit? So let's go ahead and do that. I hope you enjoyed that web work that I plan on writing for you to practice finding currents using mesh currents. And we're going to do a little bit of that after we find voltages. Now, again, a completely made up example. There's no sources in here, I don't think, that's actually going to cause current flow. But nonetheless, I think this is a useful exercise so that we can say, okay, how do we find voltages across passive elements? So we're going to assume these are all passive, which is a horrible assumption. But I think it's still a good exercise to teach you how to find these voltages. Okay, so we have the same mesh currents, I1, I2, and I3, and now we want to find V1, V2, V3, so on and so forth, all the way through V6. Okay, to do this, we need a combination of KCL, which we know how to write those really quickly now, right? And Ohm's law. Okay, so again, we're using our knowledge of the fundamental laws of circuit analysis, KVL, KCL, and Ohm's law. If I know the mesh currents, I can use that, and I can go find any voltage in the circuit. Okay, pretty powerful if you can find the mesh currents in the first place, and you're going to be able to do that in under 30 seconds for most problems. A minute. You got to practice. Let's see. So let's start out with V1. Okay. And let's say, how do we find V1? Okay. And I see V1 is plus on the bottom here and minus on the top. So what I want you to think about is the passive sign convention. We're going to assume they're all passive, right? And the passive sign convention is going to tell me the current flows in a particular direction. I'm hoping you're screaming it at your screen right now that the current is going to flow up. Okay, it's going to flow from high potential to low potential, or we can say the positive current is going to enter the positive terminal, and I'm really interested in that current. Okay, and I got that off of the plus and the minus because of the passive sign convention. So IR1 is equal to, and we know how to do that from the last video, right? I1 touches it and goes in the same direction. I2 doesn't touch it. I3 doesn't touch it. Done. So we know what the current through the resistor is. Finding the voltage is just a matter of saying V1, excuse me, keep my notation consistent. V1 is just IR1 times R1. Okay, so we can say that V1 is I1 times R1. And we're done. Okay, not too bad using that mesh current to find that voltage. Now, when we go find V2, it gets a little more complicated, but not horribly so. V2, okay, in order to find V2, I'm going to look at V2, and I'm going to say the passive sign convention tells me it's flowing in the, you tell me, hopefully you're thinking about it, it's flowing to the right. Okay, because it's starting at the plus and it's going to the minus. High potential to low potential. So IR2 is going to flow here. Okay, and if I want to write the expression for IR2, I can say, well, I1 touches it and goes in the same direction. Okay, I2 doesn't touch it, and I3 touches it but goes in the opposite direction. Okay, getting these signs right is important, so make sure that you know where the signs are coming from and that you're comfortable with it. If you're not, office hours, live problem sessions, all of those things, reach out and get the help you need to get the signs right because it's important. But we have that current, okay? And with that current and the resistance, we can figure out V2. Okay, so V2 is equal to IR2 times R2. We got to take all of this and plug it in there. Order of operations. Stick some parentheses around it. Okay, so v sub 2 is equal to I1 minus I3 times R2. And we're done with that one. Okay. Rinse and repeat. I don't draw the arrows. I think about it, I guess. I don't explicitly say, oh, passive sign convention tells me. I say, what's the positive direction? And then what's touching it, what's not. And we go from there. So let's keep going on these and find V3. Okay, V3. And I can write them a little quicker if I don't have to do all the substitutions, right? I can say, you know what, and let's just say V3 equals, okay, well, it looks like I1 doesn't touch V3, I2 does, and it flows in the negative direction, okay, negative I2, and I3 touches it, and it flows in the positive direction, so it's going to be plus I3, okay, all of that times R3, and that's the voltage across R3 if I know what the resistance is and the mesh currents. Okay. Keep on trucking. V4, where is it? It's over here. Does I1 touch it? Nope. Does I2 touch it? Yep. And it looks like it flows in the positive direction according to that polarity. So it's going to be positive I2. Does I3 touch it? Nope. So I'm done with just that, and we multiply that by R4. Okay, look at these. Think about your units. Amps times ohms equals volts. Amps times ohms equals volts. The units work out nicely. Okay, think about your units whenever you can. All right, let's see. Skip over here. We got 4. Is this even on the screen anymore? Yes. V5, just barely. Where's V5? Come on, scroll for me. Where's V5? There it is. Okay, does I1 touch it? Yes, and it goes in the positive direction. Okay, I1. Does I2 touch it? Yes, and it goes in the negative direction. And then I multiply by R5. Okay, and I'm done with that. I'm going to sneak over here so that I can keep R6 on the screen there. Maybe I can cheat it down. Okay, we know that this is R6 up here, and we want to find V6 across it. Okay, last one, V6 equals, does I1 touch it? Nope. Does I2 touch it? Nope. And does I3 touch it? Yep. And it flows in the positive direction. So it's I3 R6 amps times ohms equals volts. Okay. So if we know the mesh currents, we can find any current, and we can find any voltage across a passive element. We will look at an example where we need to find, and you will have homework, where we need to find the voltage across an active element. And we treat that a little differently because we don't know the resistance. Okay, it has a resistance, but we don't know it. And we'll have to lean on one of our other fundamental laws for that. But right now, if we have our mesh currents, we can find just about any voltage or any current in the circuit that we need to know. If we can do that, we can find any power too. Right? So this is how we use the output of mesh analysis. Now we have to go do mesh analysis so that we can find I1, I2, and I3 and actually calculate some values. Okay? And we're going to do that in an organized fashion. I'm excited. I hope you're getting excited. At the end of this, you're going to be able to analyze just about any circuit, even some big ones that are a little scary right now. Okay? We're going to make them not scary. So stay tuned and good luck.